Hi guys, welcome to my sharing some knowledge about these specific topics. I'm John Benedict Marcos, a student passionate about learning and sharing knowledge. Today, I will here to engage and educate you on P6, specifically covering key topics in electrotactics. We will explore different topics about it, like electrotactics, structure of atom, process of charging, Coulomb's law, electric field, electric lines of force, electric field due to a point charge, electric potential and potential difference, capacitors like series connection, parallel connection, combination of series and parallel. The first topic is electrotactics. Is the study of electric charges at rest and how they interact. It explains how objects become charged, the forces between them, and the electric fields they create. This principle is essential in nature and technology, from lighting to electronic devices. The second topic is structure of the atom. The atom consists of a nucleus containing positively charged protons and neutral neutrons, while negatively charged electrons orbit around it, energy levels, with protons defining the element, neutrons stabilizing the nucleus, and electrons controlling chemical interactions. The third topic is process of charging. The process of charging occurs when objects gain or lose electrons through friction, rubbing, conduction, direct contact, or induction without contact. Friction transfers charge by rubbing, conduction balances charge through touch, and induction causes charge separation due to a nearby charged object, explaining static electricity and charge movement. The fourth topic is Coulomb's law, the mathematical description of the force between two charges. So the first example is two balloons are charged by rubbing them with wall. One balloon has a charge of 6 microcoulombs and the other has -4 microcoulombs. If they are 0.5 meters apart, what is the force between them? So this is the solution.
First, you need to write the given values. After you write the given values, use the Coulomb's law formula. And the third step is substitute the values. After that, you need to multiply the charges. So the absolute value is 24 times 10 raised to 12. And after that, the fifth step is square the distance. After you square the distance, you need to divide it. And after you divide it, you need to multiply by k. So the final answer is the force is 0.86, and since the charges are opposite, the force is attractive.
The second example of Coulomb's law is two small spheres, each with a charge of +3 microcoulombs, are placed 0.5 meters apart. So the question is, find the electrostatic force between them.
So for the first step is write down Coulomb's law formula, whereas F is force, K is 9.0 times 10 raised to 9, and charges and distance between charges. The second step is identify given values from the problem. And thirdly, substitute values into the formula. Step 4, solve for the force, multiply the charges. Second, square the distance. And third, divide. And fourth, multiply by. And after that, if you done all the step 4, you need to interpret the answer. So the electrostatic force is 0.324, and since both charges are positive, they repel each other.
So the fifth example is electric field. An electric field is the force per unit charge exerted by an electric charge on other charges in its surrounding space. So the first example is a small charge particle with a charge of 3 x 10 -6 C. 3x 10 negative 6. C. Experiences a force of 0.09 N. 0.09 N in a uniform electric field. What is the strength of the electric field acting on the charge? So for the next, is the solution.
The first step is recall the formula. The electric is calculated using the formula. So, the second step is substitute the values. For step 3, you need to perform the division. Electric is equals to 0.09 divided by 3 times 10 raised to negative 6. First, divide 0.09 by 3. So, the result is 0.03. Now, divide by 10 is raised to negative 6, which is the same as multiplying by 10 raised to 6 is equals to 3 times 10 raised to 4. So, the final answer is electric is equals to 30,000 neutron coulomb. Thus, the electric field strength is 30,000 neutron coulomb.
The second example of electric field is an electric field of 5,000 NC exerts a force of 0.25 N on a charged object. So, the question is, what is the charge of the object? So, for the next slide it is the solution that you may see or learn.
So, we need to recall the formula. And after that, we need to substitute the values. For the step 3, perform the division. Q is equals to 0.025 divided by 5,000. Convert 0.025 to scientific notation. 0.025 is equals to 2.5 times 10 raised to negative 2. Write 5,000 as a power of 10. 5,000 is equals to 5 times 10 raised to 3. Now divide Q is equals 2.5 times 10 raised to negative 2 over 5 times 10 raised to 3. Then divide 2.5 by 5. 0.5 times 10 raised to negative 2 negative 3 and 0.5 times 10 negative 5. Convert 0.5 to scientific notation. Q is equals to 5 times 10 is raised to negative 6 coulomb. So the final answer is Q equals to 5 times 10 negative raised to 6 coulomb or 5 microcoulomb. Thus, the charge of object is 5 times 10 raised to negative 6 coulomb.
Topic is electric lines of force. Electric line of force are imaginary lines that represent the direction and strength of an electric field. They start from positive charges and end at negative charges, showing the path a positive test charge would follow. The density of the lines indicates the field's strength. Closer lines mean a stronger field.
This figure illustrates the electric field lines around isolated charges. The left side shows a positive charge with field lines pointing outward, indicating that it repels other positive charges. The right side shows a negative charge with field lines pointing inward, meaning it attracts positive charges. The density of the lines represent the strength of the field, and they always follow the direction of force, starting from positive and ending at negative charges. This diagram visually explains how electric fields exert forces on other charges in their surroundings.
For the topic number 7, electric field due to a point charge is calculated using E is equals to KQ R square, where E is the electric field strength neutron coulomb, K is coulomb constant, approximately 8.98755 times 10 raised to 9 neutron meter coulomb square. Q is the magnitude of the point charge, R is the distance from the point charge. So for the first example, a charge of plus 5.0 microcoulomb plus 5.0 microcoulomb is placed in the vacuum. So the question is calculate the electric field strength at a point 2.0 meters away from the charge. So use K is equals to 9.0 times 109 neutron meter square. C 2K is equals to 9.0 times 10 9.m square C square. So wait for the solution.
So for the step number 1, find the distances. For the second step, use the formula for plus 8.0 microcoulomb, E1 is equals to 9.0 times 10 raised to 9, 8.0 times 10 negative raised to 6 over 2 square is equals to 18,000 neutron coulomb. Points away from plus 8.0 neutron coulomb rightward. For negative 2.0 microcoulomb is E2 is equals to 9.0 times 10 raised to 9, 2.0 times 10 negative 6 over 4 square is equals to 1,125 neutron coulomb. Points towards negative 2.0 microcoulomb also rightward. Find net field since both fields point right at them. E net is equals to 18,000 plus 1,125 is equals to 19,125 neutron coulomb. So the final answer is the net electric field is 19,125 neutron coulomb to the right.
The eighth topic, electric potential and potential difference. Electric potential, the electric potential at a point is the amount of electric potential energy per unit charge at that point. And potential difference, the difference in electric potential between 2 points is called potential difference or voltage. So the first example is a charge of plus 2.0 microcoulomb plus 2.0 microcoulomb is moved from a point where the potential is 15,000 V to a point where the potential is 5,000 V. How much work is done on the charge? So wait for the solution for the next slide.
For the first step is find the potential difference. Potential difference is equals to V1 minus V2. Potential difference is equals to 15,000 V is minus 5,000 V. Potential difference is 10,000. You need to subtract that. And after that, step 2, use the work formula. The formula for work done is moving a charge is. Work is equals to Q potential difference. And after that, you need to substitute the values. Work is equals to 2.0 times 10 raised to negative 6 coulomb times 10,000 V. So step 3, solve for work. Work is equals to 2.0 times 10 raised to negative 6 times 10,000. Work is equals to 0.02 joules. So the final answer is the work done is 0.02 joules. That's the final answer.
For the last and final topic, a capacitor is an electric component that stores and releases energy by accumulating electric charge on two conductive plates separated by an insulating material, dielectric. It is commonly used in circuits for energy storage, filtering, and voltage regulation. For the first example of series connection, three capacitors of 5 microfarad, 10 microfarad, and 15 microfarad are connected in series. So the question is, find the total capacitance.
So the solution is use the formula. And after you use the formula, you need to substitute values. 1 CEQ is equals to 1 over 5 plus 1 over 10 plus 1 over 15. And after that, convert to a common denominator. LCM is equals to 30. 6 over 30 plus 3 over 30 plus 2 over 30 is equals to 11 over 30. And solve for coulomb EQ. Coulomb EQ is equals to 30 over 11 is equals to 2.73 microfarad. So the final answer is the total capacitance is 2.73 microfarad. And capacitors in parallel connection. In a parallel circuit, total capacitance is the sum of all individual capacitors. CEQ is equals to C1 plus C2 plus C3 plus ellipsis. Voltage remains the same across each capacitors. And the first example is 3 capacitors, 4 microfarad, 6 microfarad, and 10 microfarad are connected in parallel. Find the total capacitance. So for the solution, write the formula. CEQ is equals to C1 plus C2 plus C3. Substitute the given value. CEQ equals 4 plus 6 plus 10 and add the values. CEQ is equals to 20 microfarad. So the final answer is 20 microfarad. And for the combination of capacitors in series and parallel, For capacitors in series, the total capacitance is 1 CS is equal to 1 C1 plus 1 C2. For capacitors in parallel, the total capacitance is CEQ is equals to CS plus C3. And for example number 1, two capacitors 6 microfarad and 12 microfarad are connected in series. And this combination is connected in parallel with a 3 microfarad capacitor. Find the total capacitance. To solve this, we need to solve the series combination of 6 microfarad and 12 microfarad. 1 CS is equal to 1 6 plus 1 12. Find a common denominator of 12. So 1 CS is equals to 2 over 12 plus 1 over 12 is equals to 3 over 12. So find CS. CS is equals to 12 over 3 is equals to 4 microfarad. Now add the parallel capacitor. 3 microfarad is 3EQ is equals to 3S plus C3. CEQ is equals to 4 plus 3. CEQ is equals to 7 microfarad. So the final answer is 7 microfarad.